inequalities. The whole unit, number 6, is about inequalities in triangles, but today we're going to start off with some basics. And I just have to warn you, you will see some proofs. There aren't any proofs in tonight's homework, so please don't be too mad at me for the proofs in the notes. So in our first example, it says that we're given that line segment AC is greater than line segment AB, and we're also given that AB is greater than line segment BC. So AC is definitely the longest side in this triangle, and BC is definitely the shortest side. So we can say our conclusion here, since AC is bigger than AB, AB is bigger than BC, we can say for sure that AC is greater than BC. In the second part of example 1, we go back to something that we studied earlier this year. Remember, this is chapter 6, so that's why some of these things that we haven't talked about for a while are coming up. It says the measure of angle BAC, that's this angle, plus the measure of angle CAD is equal to the measure of angle BAD, the whole entire angle. And I don't know if you recall, my friends, but this is referred to as the angle addition postulate. So we can conclude from this that the measure of angle BAD, that whole angle, is definitely greater than the measure of angle BAC, which is just one part of the angle, and the measure of angle BAD is also greater than the measure of angle CAD. Okay, next we're going to take a look at some properties of inequality. And with inequalities, very often it's easiest if you replace all those variables with numbers. So in the first one, it says if A is greater than B and C is greater than or equal to D, then the sum of A plus C has to be greater than the sum of B and D. So let's do this with numbers. So let's start off with if 4 is greater than 3, because 4 is greater than 3, and 2 is greater than or equal to 1, then 4 plus 2 must be greater than 3 plus 1. So check it out, do the math. 6 is greater than 4. And you can see how it checks out. Okay, and the second inequality, or property of inequality, it says if A is greater than B and C is greater than 0, then the product of A times C has to be greater than the product of B times C, and the quotient of A and C must be greater than the quotient of B and C. So again, try it with numbers just to make sense of it. If 4 is greater than 3 and 2 is greater than 0, then this property tells us that 4 times 2 has to be greater than 3 times 2. And that would be 8 is greater than 6, which is true. And also 4 divided by 2 would have to be greater than 3 divided by 2. And that would give us 2 is greater than 1.5. And that's true as well. Right, and our third property of inequalities, it says if A is greater than B and C is less than 0, then A times C is less than B times C, and A divided by C is less than B divided by C. So stick with 4 is greater than 3. And this time we need to choose a number less than 0, so we need to choose a negative for C. And then check it out. We have 4 times negative 1 less than 3 times negative 1, which will give us negative 4 is less than negative 3, which is true. And then try it with a division. Take 4 divided by negative 1 and compare it to 3 divided by negative 1, and that will give us negative 4 is less than negative 3. Again, still true. And our next property, it says if A is greater than B and B is greater than C, then A is greater than C. Kind of reminds people of the transitive property. So if 4 is greater than 3 and 3 is greater than 2, then of course 4 is going to be greater than 2. Okay, one more. Just want to scoot this up a little bit. In this one it says if A is equal to B plus C, and C is greater than 0, then A is greater than B. And this is sort of what we saw with the angle addition problem in our first example. So let's say if 4 is equal to 3 plus 1, right? Because we have 1 is greater than 0, then of course 4 is greater than 3. So in our second example, we're going to take a look at a quick proof involving inequalities. And it starts off that we're given that line segment AC is greater than line segment BC. And we're also given that CE is greater than CD. So don't forget, we have to write given. And in part 2, we're going to take and add these two inequalities together. So we're going to do AC plus CE. And we can say that it's greater than BC plus CD. Okay? And that's just a property of inequality. Okay, and hopefully this makes sense, but if it doesn't, you can just plug some numbers in. Let AC be 4, let BC be 3, let CE be 2, and let CD be 1, just to kind of prove to yourself that for sure AC plus CE would be longer than the sum of BC and CD. Okay, now it's been a while since we've had to do the segment addition postulate, but that's what we're going for. Next, we're going to prove that AC plus CE is actually equal to the whole segment, AE. So let's say that AE is equal to AC plus CE, and BD, the other line segment, is equal to the sum of BC plus CD, right here. And again, that's the segment addition postulate. Okay, in part 4, this is our old friend substitution. We're going to take out the AC plus the CE and replace it with AE. We're going to take out the BC plus CD and replace it with what BC plus CD is equal to. And so we get our final statement, AE is greater than BD. And again, that was by substitution. So in our third and final example, we'll take a look at an exterior angle of a triangle. So we start off being given that angle 1 is an exterior angle of triangle DEF. So that's given, and this is our angle way up here. And what we know about that is that the measure of angle 1 is actually equal to the sum of the measures of the two remote interior angles. So you can say it's equal to the measure of angle E plus the measure of angle D. So you can just say the exterior angle theorem. But again, the whole thing is that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Well, if you combine line 2 with what we just talked about with the properties of inequality, this would tell us that the measure of angle 1 is greater than the measure of angle E, and the measure of angle 1 is also greater than the measure of angle D. And you, again, can just say it's a property of inequality. So our theorem, theorem 6.1, first theorem in chapter 6, says the measure of an exterior angle of a triangle is greater than the measure, sorry about that, can erase it, greater than the measure of either remote interior angle. Sorry, that word's interior. Okay, from now on, we don't have to write that whole theorem out, of course. You're going to call it the exterior angle inequality theorem.